This video is brought to you by Sporlan. Quality, integrity, and tradition. So today we have a service call on a Ruud package unit. This is a 3-ton package unit, and we actually installed this just about a month ago. So it's kind of odd that we have a problem already. Condenser fan motor is not running. I don't feel a crazy amount of heat. Maybe some oil or something right here. This is what I see when I open it up. We've got 208 coming in, 208 going out. Contactors pulled in and I got nothing. So we're gonna have to figure out why we don't have a condenser fan motor and or a compressor running at the moment. Condenser fan motor's not running. I did go feel the motor and it is hot. So we're gonna test the motor right now to see what we get. We're gonna go from the power leg to the common on the capacitor. We have 208 volts and we don't have a running condenser fan motor. Let's dive into that capacitor and see if we have a problem with the cap. So we're gonna de-energize and test that guy out. Okay, so we got this guy disconnected and we're gonna test from common to Herm. Should be a 45 and it is. Common to fan motor, and it's 5 microfarad. That's odd because it doesn't seem like it's bad. So this sucks. I'm sitting here looking into this. This unit doesn't have a high pressure control. You can see the jumper right there. This is a brand new freaking Ruud unit. I got the condenser fan motor pulled out because the condenser fan motor is bad, but hopefully I can get that compressor to thermally reset because I don't see, and I'm looking to make sure I'm not missing something. I don't see a high pressure control in here. There's only a low pressure control. Man, that really sucks. Hopefully that compressor's not bad. Frustrating. So I've got no continuity across the compressor terminals, their windings. I'm gonna go ahead and cool this guy off. I've got my cool presser on. Keep a nice steady flow of water over that thing. I really like that cool presser tool. I'll put a link in the video notes. I got no affiliation with the guys, but it seems like a pretty cool tool. Basically just gonna watch this until the windings or the thermal overload closes. Basically, we're hoping that will reset. It shouldn't take too long, but we're gonna go ahead and cool the whole head off. As long as I get that to reset, then I'm going to go get the condenser fan motor and get them going. But I wanted to see that reset before I drive all the way to the supply house and find out that I need a compressor too. So, all right, and we reset. But I'm going to go ahead and let it continue to cool it off because that compressor is pretty hot. So we're going to cool it beyond just the overload and try to cool the whole body of the compressor off. All right, so what we're going to do here is, assuming that we don't know which one is our common start and run, we're going to do a test to figure that out. So we have 3 windings. This is a single phase compressor. Okay, so we're going to go ahead and test across and we're going to get some readings and we're going to analyze those numbers. Okay, so we're going to go from red to black. Red to black gives us 1 ohm of resistance. Okay, so we're going to go red to purple. Oops. That gives us 2.68 ohms of resistance. Okay, and then we're going to go from purple to black and see what that one gives us. That one gives us 1.76 ohms of resistance. So our biggest resistance value is going to be across our run and our start winding, and that was purple and red. So what that tells you is that the leftover color is your common. So then what we can do is we can take, so black is going to be our common, red is going to be our run. So now you see we have 1.01 ohms of resistance, and then black to purple, purple is going to be our start. We have 1.76 ohms of resistance. Now we're going to compare that to the Copeland mobile app and see what it says our resistance value should be. Okay, so we're going to go to the Copeland mobile app, enter the model number ZP K5E PFV. This is our model number right here. It's an air conditioning 230 volt single phase. We're going to go to electrical. We're going to go to winding resistance. And we're going to see that our run winding should have a 0.89 ohms of resistance, and our start winding should have 1.65. We're within range, so we're going to call that good, and we're going to go ahead and go get our condenser fan motor now. All right, I just wanted to draw this out on paper and make it make a little more sense for you guys, okay? 3 terminals on that compressor. When we measured from one terminal to another on our meter, we measured the resistance value. We got 2.68 ohms of resistance. On another 2, we got 1.76 ohms of resistance. On the last 2, we got 1.0. Mind you, there's only 3 terminals here, but we're measuring between them. So that's why I'm saying 2, 2, 2, okay? So the one that we get the terminals that we get the highest resistance value across, what you're doing is you're measuring from one end of your start winding to the other end of your run winding. So you know that those 2 terminals, one of the 2 is going to be run and one of them is going to be start. You've only got 3 terminals there total, so that means that the 3rd terminal that you didn't measure on is going to be your common terminal. Once you figure out your common terminal, then you're going to measure from your known common to one of them, and you're going to get the resistance value of 1.76. Then you're going to measure from your common to the other terminal, and you're going to get 1.0. Your start winding is going to have a higher resistance value. Okay, so from common to start is going to be the highest resistance. From common to run is going to be the lowest resistance. So you now know that the 1.0 ohms of resistance is your run winding. Okay, so that means from this terminal to this terminal is 1.0 ohms. We already know this is common, so that means this is run, and the last terminal is going to be your start terminal. So now from common to start, you get 1.76. From common to run, you get 1.0 ohms. Hopefully that clarifies and makes sense a little bit more. See, this compressor tool is really cool because it has a magnet, but it allows the water to come out of this area right here via up inside there, and the magnet allows it to sit so that way the water flows, you know, while it's still magnetized to the compressor. Super nice little tool. So I got the new motor in here. I gotta admit, I was a little frustrated because I got an OEM motor, but they didn't have an OEM cap. But I gotta say, something cool that Ruud did, okay? The OEM cap was narrower, wasn't as fat, and it had this bracket on it, but when you take that bracket off, you can fit a normal. So I was worried I was going to have to figure out a way, but look at that. That's awesome. I dig that. Good job, Ruud, Ream, whatever. So we're going to get this thing wired up, and hopefully this compressor starts up, and we'll see what else we can do. So my unit's working really well. I mean, it's under a heavy load right now, but the capacitor fit in there nice and good. Everything else wired back up. I still got to put my little connector right here. One of the things I will say that's kind of silly about these Ruud units, or Ruud units, however you say it, is pressure probes are there, whatever, but to get temperatures, you got to get inside here. You got to lift the condenser fan motor over, so that's why I have that little grommet out. I've only got 2 screws in the condenser fan motor so I can get my temperature clamps on there. So we're gonna check everything out, and actually looks like I might have a temperature clamp on the wrong spot. Yeah, I do. I got the temp clamp on the discharge line, so I got to get in there and fix that. So we are running, my condenser fan motor is allowed to run 1.5 amps, and we're running 1.05, so we're within range on our condenser fan motor. It's not overamping. So now we're going to let the system stabilize and calm down, and then we'll finish diagnosing. I think I corrected my temperature probes. Let's see if I did. Let's see, where's my temperature clamps at? Actually, I need to go back. They were right there. I just wasn't paying attention. Suction line, liquid line, yeah. So I corrected my temperature clamps. So we're just going to let the system run for a while. It's under a really heavy load right now. Let's see what my, it's about 98, 100 degrees. And look at my return dry bulb, 85 degrees. Wet bulb temperature, 66. So we're going to let this system stabilize. We're under a heavy, heavy load. This thing's been down for a day, so we're going to let it run. I'm going to monitor it for a bit, and I'll come up with a full report on Measure Quick, and then I'll also go ahead and get some electrical readings off this unit too with Measure Quick. So we're just waiting for it to come down to temp. Alright, so everything is looking really good. We've got our system operating like it should be. Sorry, I'm trying to get a better image there. We can start back over. Outdoor measurements, you know, we're all within range here and there. It's nothing I'm concerned about. This is a brand new unit we installed like a month ago, so I'm pretty confident everything's still good. I also know, I didn't measure it this time, but I do know that we have really good total external static on this unit too. It's running below a 1/2 inch. So yeah, everything else is looking good. I don't know why the electrical measurements disappeared, but whatever. I had them in there, but yep, unit's looking good, so we're gonna go ahead and wrap it up. And here I just have a printout of the Measure Quick report so you guys can take a look at it. To recap, we had a service call. It was a no cooling call on a little 3-ton package unit, and I did mention in the video we had just installed this unit a month ago, so I was a little bit worried as to why the unit went down. What I found was that the unit had a bad condenser fan motor. Okay, this was a Ruud package unit. It's a pretty decent quality unit, but obviously they lost a fan motor. And actually, I guess I should have shown it on the video, but what happened to the motor was the bearing, like it blew out or went bad or whatever. The motor itself was locked up when it was under a load, but there was a lot of grease coming out of the bearing basically. So something happened inside the motor. Anyways, went ahead and went through all the tests to confirm that the motor was bad. Also showed you guys how to do the compressor winding test because I was concerned the compressor did not have a high pressure control protecting it. So it did go off on thermal overload. Now, if that happens a lot, eventually it'll damage the compressor. So that's not something. I'm thankful that the compressor was able to reset. And I'm going to look into seeing if I can get a high pressure control for that unit. The only downside is that I would have to screw it onto the Schrader port, or I would have to recover the charge out of the unit to put a proper pressure control on there. So I'll have to think about how I want to do that. But anyways, I digress. So also showed you guys the Copeland app and how to confirm whether or not we had the right resistance values on the compressor. Okay. And that app is Copeland Mobile. You can download it at any of the app stores, whether it be Apple or Android. It's a free app. Okay. The app that I was using to diagnose the unit or to just confirm the readings was Measure Quick. That's another free app you guys are capable of downloading on either the Android or the Apple store, so that's a free one too. I was also using the Field Piece Job Link probes with the Measure Quick app. I'll have a link in the video show notes about that. And yeah, I think that's it. Also wanted to kind of show you guys how I drew out that compressor winding paper right there, so that way you can confirm what, you know, if you didn't know which one was common start and run, it's really easy to figure that out. So hopefully that helps you guys out. Really appreciate you guys taking the time to watch these videos. Throw me some comments down in the video. Send me an email to hvacrvideos@gmail.com. Really appreciate your guys' feedback, and I guess we will see you guys on the next one, okay?